Now we will look at a couple of examples of circuit analysis when the circuit has diodes. Of course, I will take a very simple circuit, but the principles are the same for more complicated circuits. Okay. Let us take this circuit. I have a 5.7 volt voltage source. Let me call that Vs. I will call this resistor R, which I will say is 5 kilo ohms, and there is a diode D with a voltage Vd across it. And I will say that this diode has a saturation current of 10 to the minus 15 amperes. Okay. Now, first of all, we can write down the nonlinear equation, which is to equate the current in the resistor Vs minus Vd by R to be equal to the current in the diode in terms of its voltage, which is Is exponential Vd by Vt minus 1. Okay. And if you solve this equation using Newton-Raphson iteration or any other technique, you will find that Vd is 0.72 volts or so. Okay. And you can also find the current here Id by substituting that into Vs minus Vd by R or into the right hand side of this. Okay. Of course, our interest is not in numerically solving these nonlinear equations, but to use suitable approximations. Now, the approximation we said we will use or we can use is that if there is a substantial forward current, then this Vd will be fixed to some value, which is Vd on. Of course, Vd equals Vd on if Id is greater than 0 and Id equals 0 if Vd is smaller than Vd on. Now, because the characteristic is given as this conditional, there are two possibilities. You have to evaluate both. Okay. And this is the general principle. So, any diode in the circuit can be in the on state or the off state. You have to assume the two cases. You have to check the two cases and see which one leads to contradiction. Obviously, that is the wrong one. Okay. The other one is the correct one. And for this circuit, it is very easy, but I will just still show you to illustrate the principle. First, I will assume an on diode. This is where I have assumed the diode to be on. So, which means that the diode voltage is 0.7 volts. And if you make the other assumption, that the diode is off, in that case the current through the diode is 0 and I can replace the diode with an open circuit. Okay. Okay. And let me evaluate the two cases. So, first of all, if I assume the diode to be on, then I have 0.7 volts across this and 5.7 volts here. So, the voltage across this resistor is 5 volts. So, the current in this is 1 milliampere. And clearly in this case there is no contradiction, because the diode voltage is 0.7 volts if there is a forward current flowing, and with that assumption we calculated this and found that the forward current is 1 milliamp. So, what we calculate is consistent with that. But let us see if we had started off from the other assumption that the diode is off, then the diode is off, this is an open circuit, no current is flowing through this. So, the voltage across this is 0 and the voltage between these two terminals, which is the voltage across the diode, will be 5.7 volts. Now, we know from the diode characteristic that the diode voltage cannot be more than 0.7 volts. I am referring to the approximated characteristic. Okay. So there is a horizontal line up to 0.7 volts and a vertical line after that. So you can easily see that 5.7 volts is not part of the diode characteristic at all. Okay. So this tells you that there is a contradiction. So this is the incorrect assumption and this is the correct one. And you can just go through the same exercise by making this minus 5.7 volts instead of 5.7 and see where you arrive at a contradiction. Now this circuit is extremely simple. The point of doing this exercise is to go through all the logical steps and make sure that you understand every step. Now when you have multiple diodes, if you have a circuit with n diodes, then there are 2 to the n possibilities. Okay, that is, every diode can be on or off, and if you take all those combinations, there will be 2 raised to power n possibilities. And in principle, you have to check for all of these. That is, if you have 5 diodes in a circuit, you have to check for 32 possibilities. But of course, frequently you can very quickly dismiss some of the possibilities. You will be able to very easily see the contradiction without having to analyze them in detail. Okay. In fact, in this circuit, with even a very little bit of experience in circuit analysis, you should be able to see that current can only go in this direction and the diode has to be on. Okay. So although in principle there are many possibilities to check, in practice you have to check only a few of them. Okay. But the point is to understand the systematic method, so that if you have to do it, you have to be able to go through all the possibilities systematically. You have to consider all the possibilities systematically and eliminate all the wrong ones. Okay.